What if I told you that entire continents are being silently pushed and pulled by forces we can't see? Not just the slow grind of tectonic plates we learned about in school, but by invisible phantom giants rising from the depths of the Earth. Welcome to G Fun Facts Online, and today we're hunting for ghosts. Not the supernatural kind, but ghost plumes, massive columns of hot rock that are reshaping our world from the inside out without ever breaking the surface. For decades, our picture of the Earth has been dominated by plate tectonics. Imagine the planet's surface as a cracked eggshell, with the pieces, or plates, floating on a hot, gooey layer called the mantle. The movement of these plates gives us everything from the Himalayas to the San Andreas Fault. And to explain volcanic hotspots far from the plate edges, like the Hawaiian Islands, scientists came up with the idea of mantle plumes. Think of them as giant blowtorches of superheated rock rising from the deep mantle, punching right through the crust. But what happens when one of these blowtorches isn't quite hot enough? What happens when the flame goes out, but the heat remains? That's when you get a ghost. A ghost plume is exactly what it sounds like. The spectral remnant of a once mighty plume, or perhaps a plume that was just never strong enough to cause a volcanic eruption. It's a phantom presence. It doesn't create fiery volcanoes, but its influence is vast and long-lasting. Imagine placing a giant, warm, but not scorching, hot water bottle under a sheet of thin plastic. It won't melt through, but it will cause the plastic to bulge upwards and become softer. That's what a ghost plume does to a tectonic plate. This has two major consequences. First, uplift. That massive lens of warmer, less dense rock pushes up on the crust from below, creating a gentle, broad swelling of the land over hundreds of kilometers. It's a process so slow you'd never notice it, but over millions of years, it can reroute rivers and change the shape of landscapes. Second, it weakens the plate. The residual heat softens the rock of the tectonic plate, thinning it from below. This makes the plate more vulnerable to being stretched and pulled apart by other tectonic forces, potentially setting the stage for the birth of a new ocean millions of years from now. The East African Rift Valley is a spectacular, active example of what this kind of deep heat can do. So if these plumes are invisible, how on earth do we find them? This is where geology gets really clever, using a toolkit that's like a medical CT scan for the entire planet. The primary tool is called seismic tomography. When an earthquake happens, it sends waves through the Earth. By measuring the speed of these waves all over the globe, scientists can build a 3D map of the mantle. Since these waves travel slower through hotter rock, a huge cylindrical area of slow waves is a dead giveaway for a plume. This is exactly how they found the first confirmed ghost plume, nicknamed the Dani plume, hiding beneath Oman. It's a colossal column of hot rock, hundreds of kilometers wide, but with zero volcanoes on the surface. Scientists also use ultra-sensitive satellites to detect tiny changes in gravity, because this less dense hot rock has a slightly weaker gravitational pull. They can even measure the bulge of the land itself. When all the data points to a massive, hot, buoyant object deep underground, you've found a ghost. The Dani plume in Oman was just the beginning. Geologists are now looking at old mysteries in a new light. Take the Bermuda Rise. The island of Bermuda is the tip of an ancient, dead volcano, but it sits on a huge swell in the Atlantic seafloor that remains mysteriously elevated. There's no active volcano, no trail of islands like Hawaii, but seismic data shows signs of hot material deep below. It's now thought that a ghost plume is propping up the seafloor like a hidden pillar. Then there's the very heart of North America. Far from any active plate boundaries, the continent experiences strange uplift and even earthquakes. The theory is that the continent's ancient foundation has been repeatedly weakened over billions of years by plumes that have long since faded. The ghosts of plumes past could be responsible for the subtle, ongoing movements of the entire continent. This discovery of stealth plumes is a game changer. It means the Earth is far more dynamic than what we see on the surface. It suggests a whole new force might be at play in plate tectonics. For instance, some models suggest the drag from the Dani plume might have been enough to help steer the Indian plate on its collision course with Asia, creating the Himalayas. If one ghost plume can steer a continent, imagine what a dozen could do. It also means more heat might be escaping from the Earth's core than we thought, forcing us to rethink how our planet has cooled over billions of years. And on a practical level, understanding these deep structures could help us locate mineral resources or even predict earthquakes in areas we once thought were completely stable. So deep beneath our feet, a silent, invisible process is underway. Spectral giants, the ghosts of Earth's inner fire, are shaping our world. They lift mountains, weaken continents, and guide the slow dance of the plates. The study of ghost plumes is opening a new window into the planet's hidden engine room. It reminds us that even for the ground we stand on, there is always more than meets the eye. And the biggest forces shaping our world can be the ones we can't see at all. Thanks for listening to G Fun Facts Online.